Hey there, fellow Skywatchers. Today, we're diving into the mysterious world of recurrent nova events. While everyone's still buzzing about the recent 2024 solar eclipse, there's another celestial show that's just as captivating, the recurrent nova. But before we unravel its mysteries, let's start by exploring the link between recurrent nova events and white dwarfs. If you're already familiar with white dwarfs, feel free to skip ahead to the next chapter. But if you're not quite sure what white dwarfs are all about, I highly recommend sticking around for this chapter. Trust me, understanding white dwarfs will help you grasp the magic of recurrent nova events even better. Without further ado, let's embark on this cosmic journey together and dive into our first chapter. So, what exactly are white dwarfs? A white dwarf is essentially the leftover core of a dying star, once it has depleted its nuclear fuel and shed its outer layers, forming a planetary nebula. Considered a stellar remnant, it represents the compressed core of the star, incredibly dense and collapsed inward. However, unlike neutron stars or black holes, white dwarfs lack sufficient mass to undergo further collapse. Interestingly, the majority of stars in the galaxy, including our own sun, will eventually evolve into white dwarfs, maintaining this state for billions of years without significant change. Now that we've covered what white dwarfs are, let's explore their connection to nova events. About half of the binary systems in our galaxy involve two stars at different evolutionary stages. Imagine one star has evolved into a white dwarf, while its companion remains a red giant. When these stars orbit closely, they interact intriguingly. As the red giant expands, its outer layers may transfer mass to the white dwarf, forming an accretion disk around it. Over time, this disk can become dense or massive enough to trigger an instability, resulting in a nuclear detonation around the white dwarf. This spectacular event, known as a nova, resembles a new star from a distance. We anticipate witnessing such phenomena in 2024. The Coronae Borealis system is notable for its recurrent nova events, possibly occurring at least twice in the past. The most notable eruption was in 1946, which garnered significant attention from astronomers. However, the system was originally identified in 1866 due to its previous eruption 80 years earlier. Normally, the star is not visible without binoculars or a small telescope. Yet, during the eruptions in 1866 and 1946, it became visible as a new star, shining brightly for nearly a week. In fact, it ranked among the 100 brightest stars in the night sky during these events. When it erupts again, it is expected to be visible even in typical cities where light pollution is not a hindrance. Several studies conducted years ago analyzed the activity of Coronae Borealis in 2015 and 2016, uncovering some intriguing findings. The star exhibited a notable increase in brightness and activity during this period, emitting more radio light and X-rays. Interestingly, this surge in activity closely mirrored the events observed in 1938, just 8 years before the 1946 eruption. Additionally, further observations conducted in recent years revealed unusual dips in brightness. In June 2018, a minor dimming event occurred, followed by a more significant dip in March 2023. These patterns resembled the sudden dip observed in 1945, which preceded a significant explosive event approximately 9 to 10 months later. The prediction made in a particular paper suggested that the nova event would likely occur in January of 2024. However, it did not materialize as anticipated. Historically, nova predictions have often involved significant timeline errors. Given that the star in question is located approximately 3,000 light-years away from Earth, the margin of error for predicting such events is around plus or minus 7 months. Despite this, the ability to observe the nova with the naked eye is already quite impressive. Comparing this event to other nova occurrences reveals interesting insights. While there are only a few well-known recurrent nova events, predictions for most of them have been relatively accurate. For instance, the recent recurrence of nova in U Scorpii exhibited a peak magnitude of approximately 8. Similarly, the eruption of Rs Ophiuchi, a renowned nova, occurred just over a year prior, although it was only visible with difficulty due to its magnitude of 5. In contrast, the upcoming nova event is expected to have a magnitude of 2.5, making it significantly brighter and easily visible from a typical city. This rarity of occurrence happening once every 80 years, adds to the significance of the event. The pressing question arises: when precisely will the nova event occur, considering the limited window for observation? The current prediction places it in April, with a margin of error of plus or minus 3 months. In other words, we can anticipate the event to unfold between April and September of 2024. By September, the nova should have already occurred, given the striking resemblance of current observations to previous nova events in 1946. In conclusion, the recurrent nova event anticipated for 2024 promises to be a remarkable celestial spectacle. Understanding its connection to white dwarfs sheds light on the intricate processes shaping our universe. Despite past prediction uncertainties, advancements in observational techniques offer hope for accurate forecasting. That concludes today's episode. If you found it fascinating, don't forget to hit the like button and share it with your friends. Stay tuned for our next video, where we'll delve into more intriguing discoveries. Until then, keep exploring and stay curious.